All right. Hello, everybody. Okay. Welcome everybody to an info session um, today on the Study Hi-Tech in the Netherlands Alumni Edition, whereby we will be talking about the NL alumni who have actually studied in the Netherlands on the semiconductors and would like to actually explore what they're doing today. Welcome. I know some of you have actually attended today's sessions after work or after your universities or your studies at the moment. So thank you for making the time at this evening. I'm very excited to know that we have a lot of people that are very interested on understanding a deeper informations on semiconductor environment. So if you've actually attended the first info sessions that we've had on Hi-Tech in NL, whereby there was a lot of, there were information, that was informations about the universities available in the Netherlands that focus on high-tech ecosystem, but most prominently on semiconductor. So you've learned about their background, you know what their study programs are, but today's second edition, it's more about what you do with the degree that you will later get from these universities in your career. So today we don't only highlight the opportunities to study semiconductor related programs, but also to learn from three Indonesian alumni who have studied in the Netherlands and currently working or have been contributing to semiconductors and the broader high-tech ecosystem. So we want to let you know what can you look forward to after studying in the Netherlands. But before we begin, just let me briefly introduce two key organizations that are working together with Nuffic Southeast Asia today to organize this info session. The first organization is I4, or Ikatan Ilmuwan Indonesia International, which is a global network of Indonesian scholars that are based overseas. And these organizations connect Indonesian scientists and researchers and innovators around the world to basically strengthen Indonesia's knowledge ecosystem and support collaborations and research and in educations. And another organizations that we have today is ICDEC, or Indonesia Chip Design Collaborative Center. This is an initiative that actually brings together universities, agencies, governments, and even industries to strengthen Indonesian semiconductors and chip design ecosystem. Their aim is basically to develop local expertise and support talent development, which is what our goal is today for this info session, to prepare future generations, such as all of you here today, to take part in this rapidly growing field of semiconductor studies. And that's exactly what this session about. So we want to see how studying in the Netherlands can actually open pathways to global careers in semiconductors and STEM field, as shown through the experiences of our three speakers today. So I will briefly introduce you to these speakers, but they will explain a little bit more about what they do, how they studied in the Netherlands, and what brings them to where they are today. So the first speaker would be Pak Fatwa Firdaus Abdi. He is an alumni from TU Delft, followed by Pak Rian, or his full name is Alrianes Bachnas. If I pronounce it wrongly, I apologize, but you can also correct it during your session. He is an alumni from TU Eindhoven. And last but not least, it's Pak Rahmat Mulyawan, who is also from TU Delft. So each of them, again, will share their journey from studying in the Netherlands to building a career in the semiconductor industry and beyond. So without any further ado, I would like to invite Pak Fatwa Firdaus first to introduce himself and begin his presentation.
Thank you very much, Masrid. Thank you very much, Nuffic Southeast Asia, for the kind invitations and also the opportunity to share a little bit about my experience. So the way that I understand this event is more of a sharing session. So I'll share my experience, and it's going to be very brief, and out of which, if you have any questions later on, we can sort of go into more details of that. Let me share my screen. Right. Is it visible?
Yes.
Okay, great. So yeah, so my name is Fatwa Abdi. I'm an associate professor at the City University of Hong Kong School of Energy and Environment. Currently, I'm also trusted to be the chairman of this I4 or Ikatan Ilmuwan Indonesia International that Basrit just now explained a little bit about. If there's any questions about that later on, also feel free to do so. But the main thing that I want to share is my journey, starting from, I mean, I put a title here, from silicon chips to solar fuels and chemicals, because I started from my background in semiconductor, but now you see a traditional sense of semiconductors, but now my research topic is already actually beyond that. So as I mentioned, my starting point is pretty much a classic semiconductor foundations. I came from Jakarta. I grew up there, but my first degree actually comes from NTU Singapore. I did my Bachelor of Engineering at the School of Material Science and Engineering with the specializations in semiconductors. So this was in the early 2000s. So Singapore is really doing a lot of work in building up their semiconductor expertise. So a lot of basically most of my classmates in material science were doing materials for semiconductors. Even my final year project is on interconnection. So it's a three-dimensional interconnections in microelectronic and IC packaging. And naturally, I'll continue on. After that, I continued for my master's degree. So I did a program at that time under the Singapore MIT Alliance. So I got my at NUS Master of Science, at MIT Master of Engineering, both also in advanced materials for micro nano systems and material science at MIT. So the topics are also very much in a classical semiconductor industry. So I did the defect reduction in semiconductor processing, as well as the technology analysis on optoelectronic packaging. I did have some experience at the semiconductor industry itself. So I work as an intern. This is as a part of my Master of Science study at NUS at the Systems and Silicon Manufacturing Company, or SSMC. This was a joint venture between, at that time, it was between a TSMC and Philips, if I'm not mistaken. So there goes the ties with the Netherlands. But I think since 2006 or so, the share of Philips has been bought by other company, NXP or something. So I was an intern at the process integration. So we're looking at the reduction, improving the yield of a particular process. And then I was also working at the Intel Micron Flash Singapore. So this was a joint venture between Intel Semiconductor and Micron, Intel and Micron Semiconductor, sorry. So we were working on the making of a NAND flash. So that's the memory device. I was in the dry etching team, so in the process of in the process line. And this was the end of my classical semiconductor foundation experience. And before I go on to talking about how I pivoted and enter my step in the Netherlands, I maybe since I don't know whether all the audience is actually aware of semiconductor, I give a little bit of just one slide on what is semiconductor, right? So so there are basically, if we want to classify materials, there are three category. You have your metal or your conductor, which readily allows flow of electric current. So it has a lot of free electrons, so you can transport electricity. And then at the other end, you have insulator, which has a very high electrical resistance. So you cannot really flow electric current through that. And in the middle of it, you have your semiconductor. The electrical conductivity is moderate, so that's nice. But what is important is that it can be controlled by external factors. So this is the highlight here, can be controlled by external factors. And the external factors could be many things. It could be temperature, doping or impurities. It could be applied voltage. So the applied voltage part and the doping part is actually what's the underlying factor the underlying principle behind the microelectronics industry, the use of semiconductor in electronic industry. But you can actually also modify it with light. And this is where the connection with my PhD in the Netherlands comes, right? So So when I did my PhD in the Netherlands, I started from what I knew. So I actually knew on semiconductors for information processing, or electronics or microchips. But then I joined the Department of Chemical Engineering, where they're more interested in using for materials for energy conversion. So they actually try to use semiconductors not for electronics, but for photoelectrodes in order to produce fuels and chemicals from sunlight. So I mentioned earlier that with semiconductors, you can also modify the electrical properties with external factors, and one of them is light. So here we utilize the sunlight in order to illuminate the semiconductor, and therefore creating carriers, what we call that, electrons and holes. And on the surface of this semiconductor, now we perform chemical reaction. One of the reactions that we see is the productions of hydrogen. If some of you are knew about that, we have a lot of hype on green hydrogen lately. So the bottom line is that it's the same physics, so it's very similar physics, but it's a new application. So this is how we pivot from I pivoted from this classical semiconductor field to the new application, semiconductor for energy. So this was my group. So a lot of things that I learned. Also, I started to learn that from my group at the TU Delft at that time, and I graduated back in 2013. And I was fortunate to receive the Martinus van Marum Prize from the Royal Dutch Society for Science and Humanities for my PhD. And one of the things I want to highlight now is that the Dutch degree is actually your global passport. I actually have a lot of experience where I talk to people, and then I said that I actually graduated from TU Delft, and that has opened up opportunities, has opened up discussions, opened up network as well. From TU Delft, I continued to work for my postdoctoral post at the Helmholtz Center in Berlin. So that's a Center for Materials Energy, Institute for Solar Fuel. So I started working there as a postdoctoral scientist, and then I was promoted to senior scientist, and later to be the deputy head of the institute. So I spent 10 years in the research center until 2 years ago when I moved to City University of Hong Kong School of Energy and Environment. Here, I'm working on similar fields, so still using solar energy. So my group is working on sustainable technologies for chemical conversion. So we use now more input into our system, but still at the very heart of the system are the semiconductors. So the semiconductors are the ones that are taking the solar energy, and then we're making multiple chemistry in order to apply for multiple applications. So the semiconductor principles is used for global energy and sustainable solutions. And these are my research group right now. So with that, I would like to just end my sharing session by giving you 3 takeaways. The first one is that having your core knowledge is important. So this is a versatile toolkit. So it's important to enable yourself with your core knowledge. So one of the things that I wrote over here is that the skills that you learn, whether it's semiconductor physics, in my case, it's actually not for one job, but it's actually for a spectrum of different high-tech fields. So the photoelectrochemistry, data analysis, materials characterization, problem solving, at some time it may seem to be only applicable to what you were working on, but they could very much be used for all different problems, as well as other soft skills. So this is actually one thing that I learned a lot from my time in the Netherlands. So how they're forming opinion, how you are communicating with each other, and how discussions is done very openly, and how networking is done. Those I learned how to manage a research group. This is something that I learned during my time over there in the Netherlands. The second is that I already mentioned earlier that a Dutch degree is actually a global passport. So you could it's recognized worldwide, right? So and the network that I built during my time in the Netherlands is giving me a lot of a platform for me to grow. Like I later on in my career there was and even until now there's still a lot of connections that I have with some colleagues in the Netherlands. I actually hired a postdoctoral researcher in my group right now because of recommendations from somebody in the Netherlands that I knew before. So So this is something that needs to be considered during for your career growth. And finally, my last takeaway is that embrace the pivot. So your first job, or whatever it is, it doesn't have to be your last. So even if you are in one direction, it is possible to go to the other directions. So open up the new field. So be open to where your skills can make the biggest impact, and it can very well be not in the same field that you're starting. With that, I would like to end my sharing. Thank you very much, and I look forward to the discussion. Thank you very much.
Right. Thank you so much, Pak Fatwa. It was very enlightening. I think it's important to learn about your background also. It's amazing that you have a very diverse background, and I think it's inspiring also for some of the students here. There really is so many ways to actually reach to your destination. So I hope it inspires a lot of people here that Netherlands can indeed be considered as one of the pathway for students to take and to explore themselves and support the future of semiconductors and STEM field. Thank you so much, Pak Fatwa. Next, I would like to invite Pak Rian on the screen to also tell us a little bit on his experience at the Dutch universities and now what he's doing, how he gets there, and does he have a similar experience that Pak Fatwa just mentioned. Pak Rian?
Yes, thank you for inviting me in this session. Indeed, I have the same understanding with Fatwa before, that this is a sharing session, so I will try my best to share my experience and all this kind of thing. However, unlike Fatwa, I didn't prepare any slide to help me explain the presentation or the sharing session. I do want to take a different angle for semiconductor. I don't know if this support a bit more interactive session, but does the attendants in the audience know what how reliant we are to semiconductor, right? In your phone, on your EV, or any other part. Does the attendants realize that we are very, very reliant to semiconductor? I hope the answer is yes, right? Else my whole thesis is just going to crumble down. So if I am just trying to relate to the latest AI boom that we are, I think if you see global industry, global market, and all these kind of things, you will see that the top Magnificent Seven, or the top company in US, they are more or less have a relation with AI, right? AI over here is a bit more jargonic, a bit more like a hyper trend, would say. However, if you try to map this the supply chain or the actors over there, right? Maybe you heard OpenAI, ChatGPT, everything. You need to have an enough computation to be able to train those models. That's where NVIDIA, AMD plays a role. And if you want to have enough computation, you have to have this latest, greatest technology on the CPU, GPU, DRAM, etc. And then you will start to know, going down a bit in one layer, you will know, hey, this NVIDIA, how do they procure their chip? Or Apple, for example, your latest iPhone, how do they procure the chip? Or Samsung, how do they create a chip, the DRAM sense, in the CPU sense, etc. Then you start to know there is company like Micron, Intel, TSMC, Samsung, among other, that are critical players for this, especially on the high-end technology. Yeah? There are, of course, different market segment for semiconductor. There's also some that have like a mature or mainstream technology, which our company is also dealing with. But for the high-end semiconductor, those company, the aforementioned company that I tell earlier, they are relying to one company, and that is ASML, in their litho process. So if if you don't know litho process, right? If you have a bit of electrical background, or maybe in the high school you learn about electrical circuit, when you try to put your pattern in a PCB, right? You try to transfer the pattern into PCB. It's simple. If you have a big circuit, you put a pattern, you put in the PCB, you put a bit of chemical stuff, Fatwa know it better than me, and then you get the electrical circuit that you have. Great. Now, that if the pattern is big and what you want to print, the medium that you want to print is also big. Now, imagine in your cell phone or in your PC, how tiny are those the chips, right? And now we are actually entering, in terms of the feature that we want to print, we are entering not just nanometer scale, we are entering angstrom scale, right? It is even like, yeah, you can, in layman term, it's really as thin as your hair, or even like thinner. That's where the criticality, and that's where the technology start to converge to this one single, I think some new text that even says obnoxious little company in Netherlands. That is ASML. So we as ASML over here, we are in one of the critical supply chain of the semiconductor, right? We grow together with our customer because they need to move forward to this Moore's laws. We also need to move forward with them. So that's a bit of different angle of semiconductor from the practical side, right? Fatwa is already telling the technical side. I will tell just the practical. Now, a bit of the rundown or history. In fact, spoiler alert, when Fatwa start at Delft, and also Rahmat over here, we are at a similar time frame. So I did my master at Delft, 2009 to 2010. Before that, I did my bachelor at Bandung Institute of Technology, actually at the same school year as Rahmat over there. So he's my long-term friends. And then after bachelor, going to Netherlands for a study at TU Delft, then I have a chance to continue doing my PhD in system and control in TU Eindhoven. And TU Eindhoven, if you start to get a bit curious of ASML, then you learn that ASML is in the Eindhoven. And actually, Eindhoven was a Philip town before, and now, well, it's more or less an ASML town, right? People over here, like 80%, 70% are working for ASML. So the exposure to the industry, and this is what I also felt in Eindhoven and also in Delft, to be honest. Delft have a lot of semiconductor exposure as well. Although the closer you are to the source, you are going to feel it a bit more. So the PhD project, maybe have a joint venture, even a master internship, etc. There's a lot of opportunity, of course, for you to get a bit of knowledge, to know a bit of the industry, to also get a bit of a head start compared to everyone else. So that's after I'm done with the PhD, that I start to join ASML. I did start from engineer in a customer support, in which we are basically problem solving and try to make sure that customer can use our product the best. And then after some years as an engineer, I become a project leader in ASML. And from a few years back, then I become the product manager in ASML. I think the definition of product manager is quite generic, right? So my responsibilities, I'm responsible for the full cycle of the product line. One of the product line in ASML, we have plenty of product. So basically, And each of those product manager, they need to know what the customer need, also their roadmap, the customer roadmap. When do they need what kind of technology? We need to also do a market research from all over the world. What is the total addressable market, serviceable market, etc. And then we, of course, collaborate with the technical team to do the feasibility. Do we have the technical stuff to be able to create such a product? And then to define the strategic and product positioning until we are able to roll the product out, get the customer to adopt our product. And going back to what I'm saying, to help them proceed forward to the Moore's law. Because I think when they are successful, we are successful, the mankind will be happy. That's all I think from my side.
Thank you, Parian, for your experience. Especially, I think what a great introduction to us, the students, on where if we're actually aware of semiconductors, where the chips are in our phones. I think a lot of us, even I myself, are not very aware that it's such a fundamental thing that has been involved in our lives from the beginning, apparently. So there is definitely a future in semiconductor. There is definitely a need from students to be involved in this field. So yeah, thank you for sharing that little bit of experience of you. And I'm pretty sure some of our potential students here are also have any questions and would definitely ask later during the Q&A. Next, I would like to invite Pak Rahmat Mulyawan, also another TU Delft alumni, to also share a bit of his experience during his studies and also later on in his career journey in semiconductors or the STEM field. Hi, Pak Rahmat.
Hello. Okay. I will share my screen. Can you see presentation? Hello?
Yes,
Yeah.
clear.
Okay, right. So yeah, good evening, everyone. First of all, thank you to Novik Southeast Asia and Hi-Tech and Semiconductors organizer for inviting me to this sharing session. It's an honor to be here among the fellow alumni and future innovators. So you already hear from Fatwa, an academic excellence and global perspective, and how he's shown how Indonesian researchers can stand shoulder to shoulder with the best in the world, and also from Rian, who represents Industrial Frontier. He's basically in the dream company for anyone who wanted to be in the semiconductor industry. And I'm come from education and R&D side back in Indonesia. My name is Rahmat. I'm currently assistant professor at Institut Teknologi Bandung, ITB. My research focus is in chip design and photonics and also electronics. So I'll just share a short story about my experience learning in the Netherlands. I did my master at TU Delft, but at that time, not really in chip design. My focus was more on wireless communication, specifically developing wavelet-based 5DM system. And at that time, I was obsessed with signal processing. So and Delft was such an eye-opening experience. Yeah. You're surrounded by people who are not just doing theory, but constantly asking how can we build this? Can we make this become real hardware? And I think that's what stuck with me the most. Yeah, the Dutch blend of academic depth and engineering practicality. And that mindset carried over when I come back to Indonesia and joined Institut Teknologi Bandung. I started working more closely with people who were developing hardware and IC design. eventually led me to be involved with ICDEC, yeah, Indonesian Chip Design, Collaborative Chip Design Center, which focus on building Indonesia's chip design and education ecosystem. So in a way, my journey came full circle from wireless communication in Delft to becoming faculty at ITB, and now helping build the foundation for next generation of chip designers that will enable those communication system that I'm interested in the first place to be implemented. Now, if we zoom out a bit, in the last few years, as Fatwa and Rian mentioned, there's been growing attention on semiconductor, right? And back here in Indonesia, we've seen also a hint of that momentum where more students are getting into digital design and more collaborations between universities on semiconductor with the industry. But of course, there are limited access, if you like. Yeah, so there's some limitations, and we fully understand here in Indonesia. We're not trying to reinvent what ASML or TSMC are doing. Yeah, I'm sure you have already heard about TSMC and ASML, the giant semiconductor companies. But I think in Indonesia we can strengthen the talent pipeline, yeah, the design knowledge and the innovation ecosystem, if you like. And that's exactly where ICDEC, the Indonesia Chip Design and Education Center, comes in. Basically, we are, I'll just skip the boring part of my presentation. So semiconductors here is one of the priorities for the current government. Now, yeah. So basically, ICDEC starts from a simple question. If Indonesia wants to play a role in a global semiconductor industry, where do we start? And I think the answer is pretty clear. We start from design education, yeah, because fabrication or manufacturing of chip fab costs billions of dollars, and we might not have the luxury of doing that in the short term. But designing a chip, that's something I think we can already do, yeah. And what we need is talent, tools, and community that works together. And that's what ICDEC focus on. We train students and researchers across universities to design chips using modern design flows, often based on open platforms like RISC-V, but we also have a collaboration with ARM. And we also help connect universities with industry, so students don't just design for simulation, but actually build something that can be used in real applications. So this is our building, ITB Innovation Park in Gede Bage, our HQ. This is the board, and many of our projects are still related to communication, signal processing, accelerator. So for me, it's a nice bridge between my research interest and the world of hardware design in general. And beyond, so this is the member of ICDEC. So we are a consortium of 16 universities in Indonesia. Some of them, I think you already heard, like UGM, UI, and also many of our friends here. And beyond training, ICDEC also acts as a collaboration hub. So basically working with government research institutes and international partners, of course, from Taiwan, Japan, and hopefully soon the Netherlands. The goal is not just to make chips, but to build more about building ecosystem where students, researchers, and companies, startups can together create the technology that supports Indonesia future infrastructure. So this is the IC design training that we had in collaboration with Polytron. Yeah. So it's a formal training program, hands-on experience. We also had collaboration with Taiwan, and of course the Netherlands. Yeah, Hi-Tech and ASML and IMEC. We have collaboration with IMEC as well. So to wrap up, if I could summarize takeaways from my experience, the semiconductor world may sound complex, but it's really just a mix of curiosity and collaboration. My original background is not from semiconductor per se, but eventually here I am. So doesn't matter whether you start from telecom from computer science or physics. There's always a way in to semiconductor research, semiconductor industry, and for potential students here who are thinking about studying abroad, I think I would say the Netherlands is a great place to start, because the education is practical, and you will meet people like Fatwa said who might become your collaborators years later, like what happened to me. And because it emphasizes on hands-on learning, so you don't just study theory, you build things, and your project will feel connected to the real world. Yeah, and also you'll get international exposure, of course. And you get industry proximity. Yeah, because ASML, you will meet engineers from ASML, from Philips, like Rian said, and also you will have career flexibility. Like Fatwa said, a Dutch degree gives you like credibility everywhere in the world. Yeah, it's not so it's not just a qualification; it's more like a network pass. Yeah, that gives opportunity for years later. So I would like to say that it's an honor to be part of this alumni circle, and the Netherlands gave me the foundation and how I think, how I work today, and being able to bring that experience home, especially now I'm in ASIDEC, feels like making it full circle. So for those of you planning to study in the Netherlands, don't think of it as leaving Indonesia. Think of it as expanding Indonesia. So learn as much as you can, and bring that spirit of collaboration and curiosity. So that's probably from me. Thank you very much, and I look forward for a discussion after this. Thank you.
Thank you very much. Thank you very much, Pak Rahmat. That was it's a very nice thing to say, to expand Indonesia. I think that's what I think our government and everyone of here want to do, is basically to really expand Indonesia to the global network, because we really are. I mean, the fact that we have these three amazing alumni who have already gotten their educations, their informations, and able to not only expand their careers, but also their communities and countries and also industries. So it's great to know that the Netherlands can be part of that journey for the three of you. And with that being said, we will dive in a little bit deeper on the questions and answer. And I already see some questions now on the chat. There's also a hand raised there. Maybe we'll go with the chat first, since there's there's from Babam, Parianto, if it's okay. Pak Babam, I will read it for you. The questions. I'm curious about one thing. ASML is from the Netherlands, and why Netherlands did not grow the semiconductor ecosystem on their country? Is it a talent problem? And why is Taiwan can be successful to take the advantage on the equipment from ASML? What are the keys? So wow, we're really deep talk now on on the environment. Maybe any of you, bapak-bapak sekalian.
So again, I'm here for experience sharing. So there are limitation of information that I can share in this audience. one thing is so the question is good, right? Is Netherlands not growing its ecosystem? So semiconductor ecosystem is not just a fab that create a chip, right? There are a lot of fabless chip. There's a lot of how do you call it? Non-lethal part of the whole life cycle of a wafer. And of course, there are, let's say, small, medium players that the name of the company not very well heard, but there are companies that are growing in terms of semiconductor, in defect inspection, etc. I think even in Delft there was at least an ASML competitor over there, right? So yes, there is no very, very big player. I think ASML is the bigger player in the semiconductor, and even us, if you go back like maybe 5 years back, you might not even heard the name of ASML. Right now, because of all this AI chip booming, and then they start trying to find what's the alpha, and then you start hearing ASML popping up. Netherlands is growing, but not as a producent, right? There are like, for example, Apple. They have also a supply chain in NXP. NXP is a Netherlands company. Still, I hope. Maybe they sell it like Philips sell everything to every part. So yeah, it's not about the talent problem. Rahmat already mentioned it requires billion-dollar investment, right? So either you are an old player or you have a country backing you up. Because yeah, if you start from the beginning, like TSMC also start when I think the historical level is not that long, but they keep pursuing. They work with us, and then they are actually managed to become the top player, especially for the high-end chip manufacturing in logic. So it's not talent problem. Taiwan success because they have backing and also relentless pursuit. And I think if you Google it up, you will see it, or you just get some random YouTube videos to get how TSMC can become successful, or even ask ChatGPT or an AI. I don't think they're going to dream about these things. It's quite trivial, I would say.
Yeah, thank you, Parian. Other colleagues maybe would like to add. If not, I could read the next questions. All's good?
We already have official answer from ASML.
Yes,
None
Is there
official.
to add?
the person himself.
Non-official.
Right. Okay, then we move on to the next questions because I see a lot of hands also. Still on the chat. Dear speakers, given the trade ban against China for high-tech industry, could ASML still assisted Huawei to ramp up their semiconductor high silicon industries?
Right. So this is where I told earlier, there are things that I can not share in this kind of audience. So if Rahmat or Fatwa want to answer this, please go ahead. I'm not going to say anything. I'm sorry.
I'll just add just a bit from my point of view as an outsider. And Rian mentioned NXP. I believe it was just nationalized by the Dutch previously. I think it was Chinese owned, and then it was national just now. I think not too far ago. I think the geopolitics of this semiconductor industry and players in the world are quite complicated. So it's not straightforward. But I would like to recommend all of you who are interested in this to read a book. It's already actually from a few years ago. It's called Chip War by Chris Miller. I think it will give you at least a basic foundation on how this kind of geopolitics shape up until now. Yeah, and then if you're interested in more about ASML, I would like another book. I would like to recommend another book. It's called Focus, or the ASML Way by Mark Hijinks, I think, a Dutch reporter, which is very good. Probably one of the eye-opening books that I read that opened my perspective on how ASML could become the SML today. Yeah, I think that's might be just a bit from me.
Yes,
I just add very briefly. This I'm not dismissing the questions, but I think this kind of questions are questions that are above our pay grade, and we cannot do anything about it anyway. So why worry about it? That's probably my answer.
Thank you, Fatwa. That makes sense. Absolutely makes a lot of sense. Okay, we have to move on to the next question. I see a hand raised, maybe from Pa Agus Suharsono. Would you like to ask your questions away, Pa Agus?
Yeah, sure. Yeah, well, thanks for the opportunity, and thanks for the three speakers for the nice and insightful talks and interaction and their sharing. So I have two questions. My first question is specifically for Pak Rahmat, as from ICDEC, I suppose, and also part of the consortium. Like speaking about the grounding steps to build the semiconductor environment in Indonesia. So what are, like, in practice or practically the like activities or probably events or training that are basically implemented by ICDEC and its consortium in Indonesia to to boost the talents, to basically to put some grounding steps for building semicon environment in Indonesia. That's my first question, and if I'm allowed to throw my second question, probably that is also for Paramat, but probably for generally for all the three speakers. Following on my first question, we all know that engineering tools are very expensive. Like Cadence for tools will cost like 10K euro per seat, for example. Even MATLAB costs like a lot. Like based on your guys' experience, since like most of Indonesian university are constrained with tools because they're expensive. How do you think probably ICDEM or probably its consortium or Indonesian universities can tackle this issue to to avoid the restriction, to avoid the constraint of expensive tools to boost the semicon environment in Indonesia? That's all from myself then. Thanks for your answer and sharing.
Okay, thank you very much, Pak Agus. In ICDEC, we put like priority, focus on developing talent, human resource, of course. So as I just showed you the slides, so we have the IC design training by collaborating with industry, a 4-month training program with Polytron, and more on the policy side. So we are coordinating with the government. Specifically, we are trying to convince LPDP as the funding agency to create scholarship specifically aimed at semiconductor talent development. Because currently the government still don't have special targeted scholarships or strategic scholarships to specifically develop talent on this industry. Even though, as you may have heard, one of the I can say one of the roadmap for Indonesian semiconductor development is actually to build more ATP, so assembly, testing, and packaging facility, and that will need a lot of human resources. So we're still doing everything that we can, especially to get the full support from the government. But we also starting a collaboration and initiatives by our members with our respective partners, yeah, like in the Netherlands and in Taiwan mainly, yeah, and also hopefully other partners from Asia like Japan and Korea can also join. But mainly our main focus right now is more on the talent development. Yeah. So we need to have a critical mass of semiconductor engineer to actually to become something that we can ensure that the government will have a worthy effort to build, because sometimes it's more difficult actually convincing the government on how important this subject in the future until it becomes too late, which we don't want to happen. Yeah. And maybe on your second question about the tools, that's also we really understand that the one of the limitation in IC design is the tools, because the cost is prohibitive for us to access individually by each organization. But I think we can also copy the approach from our neighbors, like in Singapore and Malaysia, where the government also facilitate the tools for the consortium or for startups, basically part of the incubation for the startup industry to foster the number of semiconductor companies, especially started by young generations, younger generation, and also to facilitate a faster time to market and to become cost effective and eventually be competitive, because as my colleagues here had already explained, semiconductor it's not a one pipeline process. It's actually a web of thousands of players with very complicated relations. But that also means there are many opportunities, to supply each of these players, with what they need. So we believe there is a lot of opportunities also in chip design, and currently we have collaboration with Cadence to provide the tools for ICDEC members. So our students can use that and also learn how to about the ecosystem from there. But to actually build something, in the end, we have to think about how we can lower the barrier. Because I will give you an example, like India, for example. India already have SoC platform called Shakti. Sakti in bahasa Indonesia maybe. Shakti. It's built by IIT Madras, and they already tapped out their design. So that's one of the limitations, because we don't have any fab here. So to actually move from design phase to actually build, taping out, basically, it's still a long way to go for us. But I don't think that will that is a limitation that we cannot overcome. So we're getting there, but at this phase, I think we're more focused on developing the critical mass of talent, so we can have more excellent engineers like Rian and excellent scholars like Fatwa, yeah, to the point that once we get the critical mass of that, then hopefully the opportunity will come. The government will also fully support us, but nevertheless, someone has to start it. So here we are, starting that one step at a time. Okay.
Thank you, Pak Rahmat. Yeah. And also thank you for the questions, Mas. Now we have, because we're almost running out of time, but we will conclude with the last two questions that we've actually discovered. Maybe Pak Amam, if you still want to ask the questions away, if you're still here. If not, then I will proceed with the questions in the chat box.
Okay, maybe let me have a question, yeah, especially to Mr. Rahmat, regarding the condition of in Indonesia about the talent tools and the community. Actually, I agree with your condition, but some of my concern is about what if why we need the talent first about this kind of condition. I think the first that we need in Indonesian is about the investor that will have some investment to our country, and the next we need some of the support from country regulation from our country to easy that condition, and after that we can pursue the talent. I have some example is now in Chinese business, yeah, especially in about the nickel processing. So in production nickel production, they also have after they have business or invest to our country, the next they will give the scholarship and to increase the talent. I think the first is about the condition of investment in our country. And if you have any information, especially about how to make the talent is interest about our target in developing semiconductor condition, you can inform us. I think that's all my question. Thank you.
Okay, thank you very much. I'll try to be concise. So yeah, you're right. Basically, we have to start somewhere, right? And the investor-related issues and also the policy-related issues, we also tackle that. So we are inviting. So each of our member actually tried inviting investors, yeah, and I cannot disclose the specific the details about that here, but I believe next year some of the semiconductor companies from Asia will open their joint venture, I think, here in Indonesia. So it's already in progress. Also, related to policy, we also had a deal with the government to make the IC deck at least our HQ as a special economic zone. So where we will have special rights to do research and made a spin-off company, yeah, from ICDEC. So they will have a special exempted tax policy or something like that, and that's already supported by the government. So we also considered that option. So, but still, the main concern, what the government always inquiry us is how many semiconductor engineers that we can produce, every year. Because that's also what is asked by big semiconductor companies when they want to open branches in Indonesia. And the government cannot answer that currently. So they kind of hope we in ICDEC can help them answer that question. So having able to produce semiconductor engineers steadily, from universities, from trainings, are very important part of the policy of national semiconductor development. So that's why we've put more focus on that. And I think I will just touch a bit about this additional question. Do you think I should consider open source community? Of course. We do tiny type out as well, open source, yes. But you might already know tiny type out is more like an educational initiative. It's more for hobbyist students, and it's totally fine to teach students, and enthusiasts, to get a small digital design fabricated. But that's not exactly serious implementation, and that's more of like compromise to keep the cost low and the process accessible, aimed at beginners. But what we envision here in ICDEC is actually collaboration between the members to actually build something that can be used by the industry in Indonesia, and also can create spin-off companies out of these initiatives. Maybe a good case like the SOC of India, Shakti. There is 5 SOC that I just mentioned. So of course we already use the open source initiative for our teaching in our universities, but to do more than that, there are a lot more that we need to requirement that we need to do more meaningful implementation, or to build more serious product, if you like, that can be considered by industries to actually use and develop in Indonesia. Maybe, that's from me.
Thank you, Pak Rahmat and Pak Aman. I hope that explains, that answers your questions. Again, we'll just go to one more questions now before we actually conclude today's sessions, because we're also we're running out of time. I think the last questions would pretty much explain the Indonesian's high-tech ecosystem. It's in Bahasa, but I'll try to translate it in English. I once heard that Indonesia plans to start developing its semiconductor industry by focusing on home appliances rather than high-end chips, like those in smartphones, laptop, and computers, which are close to Moore's law limit. And for all of the speakers here, what are your thoughts on this approach?
Okay, I'll start. I guess, I guess the arguments are there for either solutions, right? But in my personal opinion, if we start with, if we keep pushing the high-end technology, or if we keep shying away from the high-end technology and not being part of that, I think we're always going to be behind. So it is far, it is difficult, but I think we should aim for being at least competing in that level. And the approach may differ. So in this front, I think the approach that Rahmat mentioned with ICDEC kind of makes sense, because with all these things, if you look at the I think one of the plots that one of the figures that he showed just now, in terms of investment and then in terms of valuation or value addition, I think chip design indeed is the ones that's probably, there's still some investment, of course, but it's actually a lot lower if you compare it with the front end or back end even of the fabrications, right? So you don't really need the tools that you need for that. So we don't need to buy the lithography tools from ASML yet, but maybe later, right? So, but then we start with the chip design and the building of the talent. I think that's also important. So, I mean, you can buy, but if there's no talent to support it, so what, right? So I do kind of my personal opinion is that I do agree with this approach more. So if we keep working on just the high appliance, the not top of the line technology as a goal, I think we're always going to be behind. So that's my thought. Maybe the others can add.
Just to add a bit, I think I sense a bit of a hope over here, right? To move forward. And if you notice carefully, or I don't know, Rahmat, is your IC deck slide is available for the audience?
Yeah, I think I can share with the audience.
Yeah, so if you notice it, they are starting that baby step, right? Not only as a fabless, but also to tackle like more application that have lower barrier of entry, right? So it does not need to be the high-end chip, but even like, for example, a battery or a power semiconductor, that's also already quite fancy, right? That of course have a different barriers of entry. And I think, yeah, I think ICDEC, we have some people that cares about our country position in the semiconductor, and I think those baby steps need to be guarded safely until they can start walking, moving, and joining the whole big party of the semiconductor.
Okay. Lastly, probably yeah, developing like home appliance chips probably seems accessible, but those markets are already dominated by established players, right? Who benefit from mature foundries and the economies of scale. We might be more interested in like high performance, high margin if we gonna get there. Yeah, that segment of the semiconductor value chain. And as you know, Indonesia's growing demand for energy efficient and renewable system right now might have to do with that. It makes this kind of focus highly relevant domestically. And for university-led centers like ICDEC, this kind of research, for example, like Rian said about power electronics, for example, that connect multiple disciplines, right? So from physics, circuit design, material science, system engineering, cross-disciplinary nature like this support academic training and produce more versatile engineers. So it's in a way, it's kind of future-proofing our development of future talent, right? And of course, it doesn't mean that we ignore like those application, but we need to put priorities because our resources are currently our resources are limited. So so we need to think of something that has higher national impact, better alignment with research and talent development, stronger collaborative potential with industries like ASML, like IMEC, and also to provide long-term technological leadership. So all of these aspects that we need to consider to put our priorities. And hopefully with that, just like Rian said, we could make these baby steps, one step at a time, hopefully to become a more relevant, more relevant, and eventually become competitive, more competitive in the global industry ecosystem. Yeah.
Thank you, Bapak-Bapak sekalian. And I think we have to conclude the time for today. Ladies and gentlemen, once again, thank you for all of the participants here who have actually, this is such an interactive session. We want to talk about study in the Netherlands, but I think we discover more than just pursuing a study in the Netherlands, but really getting in depth to the geopolitics of it, the ideas of semiconductor. We really get a lot of engaging responses from the audience. So with that, we thank you. But again, before we actually end today's session, Nuffic Southeast Asia is also involved in the planning of the upcoming EHAF and also Hi-Tech Hi-Tech and NL Mini Fair. This is where you will actually get the opportunity to meet the 10 Dutch universities that will attend the EHAF, the European Higher Education Fair and Mini Fair, and their purpose coming to the Netherlands is solely to talk about high-tech study programs and semiconductors. It is important in the Netherlands, and they would like to also invite all of you students who are very interested, who have the potential, who have the interest in semiconductors to study in the Netherlands in the following 10 universities. So if you're interested, you're more than welcome to also join us at EHAF. These are the dates and the venues, and also registration QR code right on your right. In the Dutch embassies, we will also have a mini fair, and there's also a seminar where you'll meet some of the speakers again from the Netherlands and also who have worked in the in the semiconductors industries to talk about a little bit more, have a one-on-one sessions also with the speakers and also the exhibitors who will be here. That's pretty much concludes today's info session. Everybody, once again, thank you for attending this event, and I would like to thank you also for the speakers for such an engaging conversations and information about your backgrounds. Your experience matters to a lot of students here. Thank you, everybody, and we hope to see you at the events and also the future events that Nuffic Southeast Asia will be involved in. Thank you, everybody.
Thank you.
Thank you.
Thank you, everyone.